Well, I was using 8 A100 GPUs. I failed on this for about 3 or 4 days.
Everyone who trained a model has war stories. We asked top researchers to share theirs.
My name is Tejas. I'm a PhD student at MIT. I have been working on diffusion models and one-step generation, so trying to improve the synthesis speed of diffusion models and also applying it to other problems like deep blurring or denoising or other inverse problems.
What was the anomaly that told you something was off?
So initially I tried out several architectures. First was a transformer-based architecture, and then secondly was the UNet. When I only used a particular value of alpha, I found that the model was either collapsing or it was just producing unintelligible results. And secondly, sometimes the gradient would explode. So I knew that there was probably something wrong either with the architecture or with the training dynamics. So that's when I knew I had to diagnose something.
What ended up helping you to surface the issue?
So I basically tried to isolate how our model would work by averaging over only some subsets of alpha or by using a curriculum for training over different values of alpha. I also tried to change the conditioning mechanism. Initially I was using just some concatenation scheme, but I also tried cross-attention. And so I ablated over these various design choices, and I found that by averaging over alpha in a uniform way, but by just concatenating alpha without any cross-attention or something, that I was able to get better results. So I fine-tuned on that after I made my initial diagnosis.
And roughly, how much compute or wall clock time did the failure burn?
Well, I was using like 8 A100 GPUs for my test, so I probably think I failed on this for about 3 or 4 days. I don't think I was running for 24 hours. I would say probably like 8 hours a day on this. And then I did some smaller testing on my local 3090 GPUs, probably for another 24 hours, yeah.
What ended up being the key fix for you?
I think the key fix was actually just to keep things quite simple. I was trying very complicated things with the conditioning mechanism for this. And secondly, I did some sort of gating mechanism similar to what they use in like recurrent networks. It's a very simple interpolation scheme to sort of understand how to change the value of alpha as training continues.
Is there now a particular metric that you keep an eye on, like a hawk?
I'm looking at the gradient as training continues. I have all my simulations on 1B, so I'm like plotting out how the image looks after every step and then how the output from the neural network looks at every step. So if something looks off in terms of the magnitude or something, then I immediately flag it and go back to my run to check it.